Hello student, welcome back to lecture series on discrete mathematics guys. So already we have started lecture series based on the sets and proposition from the discrete mathematics. If you are interested to see similar videos guys, go and check in my previous playlist. You will get the similar videos. So guys, in our today's lecture I'm gonna explain to you all completely discrete difference of the sets. Okay, this is one of the operation on our set. Okay, so let's get dive into our today's lecture guys. We go understand detail what are the meaning of difference of the sets. Okay, let's consider the two set. Okay, set A and set B. Okay, so we are having two sets, set A and set B. Okay, so difference of the set, okay, difference of the set we denote A minus B, okay, or B minus A. Difference means we are taking difference between set A and B. Okay, so whether we denote A minus B or B minus A. Okay, okay, that means difference of a set A minus B like this way, and difference of the subset B minus A like this way we denote. Okay, so that means A minus B, that means the set, the element, okay, X such that X belongs to the set A. Okay, X which is the part of A, but and X which not the part of B. Okay, X should be the part of A, but X shouldn't be the part of B. Okay, that is the difference of A minus B. For B minus A, we write X such that X is the part of B and X is not the part of A. That means X doesn't belongs to set A. Okay, that means X belongs to set A, but X doesn't belong to set B is a difference of set A minus B, and a difference of set B minus A. X belongs to B, but X doesn't belongs to A. Okay, this one is the difference of two sets. So if you want, you can take it by Venn diagram. Okay, let me draw the Venn diagram so that you will get the concept easier to understand. Okay, so this one is the Venn diagram. Let me draw it, this one. Okay, so this one is the set A, this one is the set B. Okay, this one is the set A, this one is the set B. So we this part we add as some different way so that you will get the difference between the two sets easy to understand. Okay, yes, now you can see that the middle part is the intersection, so we don't have to go for this. Okay, so difference of a set A, what is the A minus B? This is the set A minus B, but the intersection part is not there. The part which is coming in a B, it is not the part of A minus B. Okay, X which it shouldn't be the part of B. That means the element which is from the part B we have to delete. Okay, so after deleting we will get this set A. Okay, like this way. Okay, this is the half circle. Okay, this is the half part which is goes to the intersection over here, and that remaining and the part of B, it is also we do not want. Okay, so this is the part we have A minus B. Okay, so A minus B is the this part. Okay, similarly B minus A, you can take it from here, B minus A. Okay, the part which is not here into the intersection, not here into the A, so this one is the B minus A. Okay, so I hope guys you all have understood what actually the meaning of a difference of a set. Okay, we continue with some of the examples so that concept will be the very clear for you all. Okay, can I take an example over here directly? So let me write the example, one mathematical example. Okay, set A, I consider set A 1 2 3. Okay, 4. Let me consider set B 3 4 5 6, 3 4 5 6. Okay, difference of a set A minus B. Okay, the A minus B means the element which is from the set A but not in a set B. Okay, what are the element which is in set A? 1 2, but they are not in the set B. Okay, so A minus B is a 1 2. B minus A, the element in a set B which is not in a set A. Okay, so we have 3 4 is there, so we have only 5 6. Okay, So A minus B and B minus A is the difference of the set A and B. Okay, I hope guys you all have understood the difference of a set. It is very easy to understand, nothing we have, but just need to understand what actually the concepts are. Okay, yes, let's continue some of the properties for the difference of sets. Here guys, let's continue some of the properties for the difference of a set. Okay, so I consider here let A and B be the two sets. Okay, so we are taking two set at the initial. Okay, so A and B be the two set, that means obviously I'm not writing universal set, that means universal set is present. Okay, so universal set, it is always present with a given set. Okay, yes, so I do not have written here that universal set, that means universal set it is a present. Okay, it not need to write at all time. Okay, so first property, it says that if we take a complement, okay, so in the form of difference we are taking the properties, so we get the difference between set U minus A, the difference of UA. Okay, the difference between set UA. Okay, that means difference of set UA is a complement, we write this way. Okay, yes, so second, difference between set to that set itself. Okay, the difference between set to that itself is a phi only. Okay, so difference of a phi to itself is always phi, always remember. Okay, fourth property, difference of a complement with a complement is a set A. Okay, difference of a complement, sorry, difference of a set A complement with a set A. Okay, difference of a set A complement with a set A is a complement only. Okay, yes, so next difference of A and phi. Fifth, difference of A and phi. Okay, that you can visualize easily by using a Venn diagram, guys, not that difficult. Okay, difference of A and phi is a A. Okay, difference of next sixth one, I will take it here. Difference of A and B is, okay, difference of A and B, we write the difference between two set A and B. Okay, is A intersection B complement. Okay, A intersection B complement. Okay, the difference of A minus B and B minus A, 7. Difference of A minus B and B minus A both are always equal. Okay, difference of A minus B and B minus A both are equal whenever A and B both are equal set. Okay, if the two sets are equal. Eighth the property, difference of A and B is A, difference of A and B is A if and only if, okay, A intersection B is a phi. A intersection B which is equal to phi, that means there we do not have any element, both are the disjoint set. Okay, so and ninth number property, difference between A and B is a phi, difference at A and B is a phi if and only if A is a subset of B. A is a subset of B. Okay, then only the difference A minus B is the phi only. Okay, so I hope guys these are the easy property that you can draw the Venn diagram and you can easily explain these ones. Okay, so it's not difficult. So we continue with the next point, symmetric difference of set. Okay, we are taking next point, symmetric difference of the set. Take here. Symmetric of a set. Symmetric difference of a set. Okay, so symmetric difference, we write this one as a direct sum B. Okay, this one is the symmetric difference we write between the set and B. Okay, let's consider set A and set B, both are the set present here, their symmetric difference. Okay, we denote this one as a direct sum B. Okay, as a asymmetric difference B, and we write asymmetric difference B. Okay, we write the asymmetric difference B X such that x such that x belongs to a minus b, okay, x belongs to a minus b, and or x belongs to b minus a. Okay, that means x which is the part of a minus b and x is which is the part of a b minus a. Okay, that is the meaning. In simple word we write a direct sum b as a minus b union, okay, a minus b union b minus a. That is very easy. Okay, and it is also denoted by some other like a triangle form. Okay, a symmetric difference b. Okay, this one is also denoted by asymmetric difference b. Okay, yes, let me explain with the Venn diagram. Maybe it will be it can be the confusing for you all guys. I will explain to you all with the symmetric difference with the Venn diagram. Okay, so this one is the Venn diagram. Okay, so I'll explain with the Venn diagram now. Okay, obviously this one is a universal set, this one is the set A, this one is the set B. Okay, okay, now see that this one is the part over here from set A, this one is this part over here from set B. Okay, so this one is the B minus A, this one is the A minus B. Okay, this one is the set A minus B, this one is the set B minus A. Okay, so whenever we take their union other than their intersection, okay, so other than this intersection part, so we take this part and this part as the symmetry A direct sum B. Okay, so this both part A denoted as asymmetric difference B. Okay, I hope you all have understood guys. It is very easy, don't have anything difficult. Okay, just need to get the visualized understanding for the concepts. Okay, that means the element x belongs to a minus b or x belongs to b minus a. Okay, a minus b element and b minus a element, which is the symmetric difference. Okay, so that middle part we do not want. Okay, so we have to delete this part as the a intersection b part. Okay, yes, we take some of the numerical examples so that you can get the concept very easy, crystal clear. Okay, example. Okay. So if I consider a as a 1 2 3 4 5 6, I'll consider a as a 1 2 3 4 5 6, and I'll consider b 3 4 5 6 7 8. Okay, 3 4 5 6 7 8. Okay, and we want the symmetric difference, asymmetric difference of b. Always remember that we have to delete similar element between these two sets. Okay, so what are the similar? These 3 is similar, 4 is similar, 5 is similar, 6 is similar. 3 4 5 6 both are the similar. So 1 2 7 8. Okay, 1 2 7 8, 1 2 7 8. This is the symmetric difference. 1 2 7 8, it is the symmetric difference for a and b. In other word, you can find out the first of all a minus b, a minus set a minus b. Okay, so what are the element in a minus b? 1 2 1 2 1 2 here, and element in a b minus a 7 8. Okay, these are the two elements present here, these are the two elements present here. Okay, and take their union as a direct sum b. Okay, we are taking union between these two sets. Okay, 1 2 7 8, this one is the difference between symmetric difference for the two sets. Okay, so let's continue some of the property for the symmetric difference of the set. I hope guys you all have understood meaning for the symmetric difference. Okay, so properties of a symmetric difference. Properties of a symmetric difference. Okay, so what can be the properties possible? Okay, so using these conditions we have to define the properties. Okay, First property I'm taking a symmetric difference with a. Okay, so if you're taking symmetric difference of with a given own set, you get the phi. Second, symmetric difference of a with a phi. Okay, symmetric difference a with a phi, you will get the set a. Okay, so third property, symmetric difference of a and u, a symmetric difference with a set u, we write universal set and a difference. Okay, and that can be the a complement. Fourth property, okay, asymmetric difference b, asymmetric difference b can be written as a union b minus a intersection b. Okay, these are the standard properties, guys. You're supposed to remember these properties. Okay, yes, I hope you all have understood these entire properties. Okay, not that easy. You can draw the Venn diagram and try explain these properties here. You will get the proper meaning for the properties. Okay, yes, these are the very easy, guys. I'm just writing this property here. In our subsequent lecture, we are going to use this property for solving the examples. Okay, as we take the example, your concept will be the very clear. Okay, so that's it here for our today's lecture, guys. Remaining part we are going to continue in our next lecture, which is the algebra of a set operation. Okay, so we have to take some algebraic concept that are the very helpful here. Okay, so that one we will take in our next lecture. I hope, guys, you all have understood my today's entire lecture. Even after, if you found anything difficult, confusing, let me know in my comment section, guys. I'll come up with the similar videos. Okay, so that's it here for my today's lecture. Thank you, everyone. Thank you for my today's lecture.